will be learning about the EC subject. It is based on 2021 regulation. Okay, so let us start with one of the easiest subject in your EC syllabus, which is EC 3492 Digital Signal Processing. Many of the students think this as degree stopping paper, but it is not like that. This is a subject in which you can score high marks in it. Okay, so this will be your degree scoring paper. And since this is my first video, let us start with a small introduction about your DSP system. Okay. Generally, all these signals are analog in nature, but the computer cannot understand the analog language. So you have to convert analog signal into digital signal, where you will be finding out the values in zeros and ones, so that computer can easily understand your digital language. Okay. So consider your voice signal as your input signal. Here your voice signal is being converted into digital format using ADC, analog to digital converter. After converting the signal, it is being sent to digital signal processor, where you can improve your characteristics of the signal. You can filter your noise, you can compress the signal. As per the requirement, you can do the modification using digital signal processor. Okay. After modification, it is being sent to DAC, where your signal is being converted into analog format, so that you will be receiving your analog signal in your receiver side, that is your speaker side. Okay. So for example, you can consider speech recognition, voice recognition, and you can consider mobile phones. In your mobile phones, for speech transmission and speech compression and all, we will be using DSP system. Okay, so let us start with your first unit. Your first unit is discrete Fourier transform, and your first topic is sampling theorem. So you must know the difference between sampling process and sampling theorem. Okay, sampling process in the sense, if you want to convert something from one format to another format, you should undergo some processing techniques, right? So same way, if you want to convert analog signal into digital signal, you have some processing techniques. First one is sampling, second one is quantization, and third one is coding. Sampling process is the process where you are converting your analog signal into digital signal without any condition. Okay, this is just a conversion process. But whereas sampling theorem states that after converting your analog signal to digital signal, it is being reconstructed back to your original form, with the condition your sampling frequency should be greater than or equal to twice the maximum input frequency. Okay, so this is given as Fs is greater than or equal to 2Fm, where Fs is your sampling frequency and Fm is your maximum input frequency. Okay, so consider this input signal, and this is sample pulse, and this is sample signal. Okay, so your Fs should be greater than or equal to 2Fm. Okay, consider this signal. X of t is equal to sin pi t plus sin 2 pi t plus sin 3 pi t. Here your omega 1 will be pi, and your omega 2 will be 2 pi, and your omega 3 will be 3 pi. From here we can find out F1, F2, F3. This will be your input frequencies. Okay, so F1 is pi will be cancelled. You will be getting 1 by 2, which is nothing but your 0.5 Hz. And for F2, 2 pi F2 is equal to 2 pi, 2 pi will be cancelled, F2 is 1 Hz. And F3 is 2 pi F3 is equal to 3 pi, F3 is 3 by 2, F3 is equal to 1.5 Hz. So from these values, you have to consider the maximum input frequency. Which is the maximum frequency? This one. So for this condition, you have to consider the maximum input frequency. Okay. So F3 is 1.5 Hz. So 2Fm is 2 into 1.5, which is 3. So your sampling frequency value should be greater than or equal to 3. If your sampling frequency satisfies this condition, you will be getting the exact original signal in your output end. Okay. If it doesn't meet this criteria, this will lead to distorted output. So the sampling frequency condition can be called as Nyquist criteria. If you want to get your original output signal without any distortion, you have to follow the Nyquist criteria for your sampling frequency. Okay. And what do you mean by Nyquist rate? When your sampling frequency, here Fs is your sampling frequency, Fm is your maximum input frequency. When Fs is equal to 2Fm, when it is exactly equal to twice the maximum frequency, it is said to be Nyquist rate. For this example, what is your Nyquist rate? Fs is exactly equal to 3. Which means if you want to get your original output signal without any distortion, you should follow the sampling frequency as 3 or greater than 3. Okay, so this is one of the most important 2 mark in this topic. Next, let us see what is aliasing effect. What happens when you break this condition? Which means when you keep your sampling frequency as less than twice the maximum input frequency, it leads to aliasing effect. Okay, so you will be getting the distorted signal in your output end. When frequency is equal to 1 by t, you know that frequency is reciprocal of time period. When you increase your frequency, your time period will decrease. When you decrease your frequency, your time period will increase. Now consider this example. This is your input signal, this is your samples, and this is your sampled digital signal. Okay. So here you are decreasing the frequency value, which means your time period will increase. Here you can see the difference between this sample and this sample. Here you have small time period and here you have large time period. So when you convert this, you will be getting the output signal like this. So this is not your original input signal. What is your sampling theorem? After converting the continuous time signal to discrete values, you have to reconstruct back your original signal with the condition Fs is greater than or equal to 2Fm. But it leads to distorted output signal. Yes? So, to avoid this aliasing effect, you should go for anti-aliasing filter or you have to follow the sampling frequency condition. Okay, that's it about the sampling theorem and Nyquist rate. So I hope you have got some clear idea about the sampling theorem and Nyquist rate. Yes, thank you for your time. See you in the next video.